Hi, Kevin. How are you doing?
Just fine, thank you. And you?
I'm fine. Thank you. I was just reading your future piece in Nature about the planetary boundaries. So I have one thing that then I found really interesting is that you argue that Earth needs to remain within the Holocene stability domain.
hmm
Could you explore that a little?
Sure. Um, First off, what the Holocene is, that's basically the period that started at the end of the previous ice age. So about 10,000 years ago, when things warmed up
Mm.
on the planet, we ended up in an environmental condition that's been pretty stable. So over that 10,000 year period, there have been variations in temperature and precipitation, those climate-like variables. But compared to the 650,000 or 800,000 years before that, that particular period, the last 10,000 years, has been unusually stable in terms of climate conditions and environmental conditions. And it's in that 10,000 year period that all of our civilizations have grown up. We learned agriculture in that 10,000 year period, and we formed cities during that 10,000 year period. And basically, the way we've taught ourselves, or the way we've learned how to feed ourselves, to govern ourselves, to create an infrastructure for ourselves, that was put together in this 10,000 year period. So that's our history, if you will. That's the common history that we have with our environment and our civilization.
Mm.
So, the point that we were trying to make in the paper is that our actions today and the fact that there are so many of us on the planet these days
Mm.
uh, has put us into a situation where it's not inconceivable that our actions can push us outside that range of stability
Mm.
that we've grown up in, and push us into a situation with which we've got no history
Mm.
and very little experience as society.
So that basically what it means. So,
Yeah, because essentially we can move into a new stable state, and it's not like we're going to destroy all life on Earth or anything of that sort. But we can move the Earth system, the coupled human environmental system, into a new stable state. But it's likely that that new state will look quite different than the one that we've grown up in.
mm. But in terms of, I mean, the uncertainties in that sort of estimate must be huge.
Sure, and in terms of what that new stable state might look like,
Mm.
that's very uncertain as well. Some of what we've come up with in our analysis are we found or identified nine essentially ways in which we might be able to push the system into a different state.
Mm.
Perhaps for me anyway, in my head and my understanding, the easiest one for me to understand is one that's called ocean acidification.
Mm.
And that basically works like when we have carbon dioxide in the atmosphere, in the air. Well, if we put it this way, of all of the carbon dioxide that we, through fossil fuel burning and land use changes and whatnot, our activities, of all of that we put into the atmosphere every year, about half of it remains there.
Mm.
And of the other half, so about 25%, ends up in the terrestrial biosphere, so plants on land, and the other 25% ends up in the oceans. And one of the things that happens when you dissolve CO2 in ocean water, or in any water for that matter, is it makes the water more acidic.
Mm.
And so you can reach a point at which a significant fraction, a whole class of marine organisms that use dissolved carbon dioxide, or essentially carbonate, to make hard shells, to make what we see these days as limestone and that type of thing. They will dissolve at a certain pH value. So, and we can reach that pH value for some parts of the ocean as early as 2050 or 2060. So that's a transition to a new state, a state that would be free of organisms that make aragonite one of the forms of solid calcium carbonate. And it would be very difficult to get back from that state unless we radically reduce atmospheric CO2 concentrations.
Mm.
And of course, that feeds back into many things. It would be a huge change in marine ecosystems that would certainly have knock-on effects in terms of fisheries and the protein that we extract from the ocean that feeds 1 billion people or more. So it's these sorts of very large-scale changes that we're most interested in, or at least in this analysis.
Okay. Well, our time is up, Kevin. Thank you very much.
Thank you. It's been a pleasure. Always nice talking to you.
Okay. Bye.
Bye now.